In the previous videos, we have created object of an class in the main method or any other method of the different class. Now the question is, can we create an object of a class in the main method or any other method of the same class? The answer is yes. Namaste everyone, I am Gyan and you are watching the session 5 of Java and Web, user defined data types. Here in this example, we have a Java file calc.java, and in the Java file we have only one class, the class main. The class main contains the method main. We have two instance variables of class main, the integer I and the float f. In the main method of the class main, we are creating two objects of type main. In the previous examples, we have created object of a class in the main method of some different class. But here we are creating objects of a class in the main method of the same class. Then after we are printing the instance variables I and f of an object whose address is stored into the reference variable m. First we need to compile the Java code javac calc.java. Compilation creates the file main.class. Then after we need to pass the class name main to the JVM, and the execution of the class main starts. Various JVM memory areas has been created. Here we have shown method area, heap and stack. The bytecode of the class main has been loaded into the method area, and now the method area contains the bytecode of the class main and other class level data, that is static variables, etc. After that, the execution of the bytecode starts from the method main. So the stack frame of the method main gets created into the stack area. The execution of the code is similar to the previous codes. The difference is that at this time we are creating objects of a class in the main method of the same class. The location for the local variable args has been created, which contains the address. Which type of address has been contained by the local variable args we will discuss in the later session of Java and Web. The next statement to execute is main m is equal to new main. By writing new main, we are creating a new object of type main. The object of type main has been created in the heap area. The instance variables I and f got their locations in the object. The new operator returns the address of this object, and the address will be stored into the local variable m of type main. So the location for the local variable m has been created on the stack frame of main, and which contains address of the created object. The similar thing happens at the next line. Here again we are creating a new object of type main whose address is stored into the local reference variable m1. And in the very next line we are printing the reference variables I and f of an object whose address is stored into the reference variable m. So here we are printing instance variables I and f of an object whose address is stored into the reference variable m. After this statement, the execution of the method main comes to an end, and the stack frame of the method main will be erased from the stack area of the JVM memory. When the method main finishes its execution, the execution of JVM comes to an end, and the JVM memory areas will be erased. So this is how we can create and use the object of a class in the main method or any other method of the same class. But there are some more concepts to discuss. Can we use the instance variables of a class in the main method or any other method of the same class? Can we use the static variables of a class in the main method or any other method of the same class? So let us continue our discussion. Similar to previous examples, we can use the instance variables and static variables by using the object references. Instance variable x is different for the two objects created here. So using the object references m1.x and m2.x, actually we are accessing the instance variable x of the different objects whose addresses are stored into the reference variables m1 and m2. But the static variable y is common for both the objects. So it does not matter how we are using the static variable y. We can use the static variable y by the reference variable m1. We can use the static variable y by using the reference variable m2. In both the cases, we are actually accessing the same variable whose name is y, because the static variable is common for all the objects. So that's how this line prints m1.x is equal to 3 and m1.y is equal to 4. And in this case also we are printing m2.x is equal to 3 and m2.y is equal to 4. But then after we have changed m1.x, that means we have changed the instance variable x of an object whose address is stored into the reference variable m1. So instance variable x of that object has been changed to 6. But the instance variable x of an object whose address is stored into the reference variable m2 is still 3. Here in the next line we are writing m1.y is equal to 7. Since the static variable y is common for both the objects, so changing it by using the m1 changes it for all the objects. So after this line, if we try to access the static variable y by using the reference variable m1, it will print 7. That's how this line prints m1.x is equal to 6, m1.y is equal to 7. m2.x is equal to 3 because m2.x does not have changed. and m2.y is equal to 7. Since y was common for both m1 and m2 and we have changed the y using m1, that's why the change also affected for m2. And we know that the static variables gets loaded at the time of the class loading in the method area. Here in this video we are discussing the same examples as we seen in previous videos, but in this example we are creating object of a class in the main method or any other method of the same class. We are not creating object of a class which is different from the class containing the method main. Since the static variables are common for all the objects, so static variables are called class level data. A class level data can be accessed by using the class name. So in the main method we can write main.x is equal to 7. So in the body of the main method we can access the static variable x or we can change the static variable x just by class reference. We can access the static variables by using the object name or by using the class name. The static variables are common for all the objects, so effects will be same. At the first line when we try to print main.x, it prints 4. And in the second line when we try to print the main.x, it prints 7 because the variable x has been changed to 7. But there is something different in this program. You can see here the static integer variable x is private. But since the method main is the method of the same class in which we are using the static private variable x, so we can easily use it by using the object reference or by using the class name. We cannot use the private static variable x in some other class just by using the object reference or by using the class name. In this code again we have private static integer variable x which is assigned by the initial value 4. In the method main we are accessing the static variable x just by writing x. You can see here we are printing the value of x just by writing the x. We are not using the object reference. We are not using the class name, we are just writing x here. Again we are changing the static variable x to 7 by just writing the x. Again we are printing the change value of the variable x by just writing x. The static members can be accessed in the main method or any other method of the same class just by writing the variable name. Because the static members are common for all the objects, so just by writing the variable name the JVM comes to know that this is a static variable and this is the variable of the same class. So in this line it will print x is equal to 4, the initial value of x. The value of x has been changed to 7 and now it will print x is equal to 7. The static variable x is the member of the same class. So the static variable x can be used in the static or non-static methods of the class main without using the object reference or class name. The non-static variable, the instance variables, cannot be used directly inside a static method. A non-static variable is different for different object. The static methods are supposed to work on those operations which are common for all the objects. Now if you directly write here y is equal to 7, then it is a confusion. Because all the objects created of type main have different y. So just writing here y is equal to 7 is a confusion. Whose y? Which object's y? So the compiler throws an error. A non-static variable cannot be accessed from the static context. This error occurs only if we try to use the non-static variable from the static context. Because non-static variable is different for different objects and the static context is supposed to work on the various operations which are common for each object. But if we try to use the instance variables inside the instance methods, that is a non-static methods, then we have seen in the previous video that writing only instance variable y actually becomes the instance variable y of the caller object. Let me try this code practically. Open main.java and this is the code. Here the method add is the static method. Inside the body of the static method, we are using the instance variable x and we are using the static variable y. The instance variable x is different for the different objects. But the method add is supposed to work on the common operations of all the objects. That's how the static methods can be called by using the object references, can be called by using the class name, or if we are calling the static method from the method of the same class, then we can call the method without using any object reference or class name. So in this case, we cannot identify the x belong to which object, since the method has been called using the class name. Without using the class name, we can also call the method add, because the method add belongs to the same class of method main. So without using the class name or method name, we can call the method add. Let me save and compile it. Compiler again throws the same error. Non-static variable x cannot be referenced from the static context. If you make the method add as instance method, remove the static word from here. Now we cannot call the method add without any object reference. Let me try to call the method add without object reference. Let me save and compile it. Java C main.java. Compiler throws an error. Non-static method add cannot be referenced from the static context. Now the method add becomes non-static. So that non-static method add cannot be referenced directly from the static context. A non-static method add is supposed to do object-specific operations. So here while calling the method add, we need to specify an object whose specific operation the method add is supposed to do. So write here m.add. So here the method add is now supposed to do a specific operation for the object m. That's how in the non-static method add, if we print x, that means the instance variable x is specific to an object whose address is stored into the reference variable m. And we know that y is common for all the objects. So y can also be used in the non-static methods. Let me save and compile this code. Java C main.java. This time compiles fine. Clear the screen. Run it. Java main. It runs fine, printing main add 3 add 4. We cannot call the non-static method add by using the class name. We cannot call like this. Main.add. Let me try to compile it. Java C main.java. The compiler throws the error. Non-static method add cannot be referenced from the static context. Main.add. So to use a non-static variable from the static method, we need object of the class. Here the method hello is the static method, and in the static method we are printing the static variable y. We can call the static method by using the object reference. We can call the static method by using the class name, or we can call the static method as it is if the method which is calling the static method belongs to the same class. In all the cases it will print hello4 and hello4. Static methods do operations which are common for each object, so we can use the static variables inside the static methods because the static variables are common for each object. But we cannot use the instance variables inside the static methods because the instance variables are different for different objects. We already seen this example. We cannot use the non-static variable inside the static method. It will throw an error. The static methods do operations which are common for each object, so we cannot use the instance variables inside the static methods because the instance variables are not common among objects. A non-static method can be called from the static method by using the object reference. Because the non-static methods do operations specific to the caller object. So in this case the called non-static method hello does the operation specific to an object whose reference is stored into the reference variable a1. In this case inside the body of the method hello we are printing the value of the static variable y. But since the static variable y is common for all the objects, so it can be used for the specific object whose address is stored into the reference variable a1 also. We cannot call a non-static method by using the class name, or we cannot call a non-static method without using the object reference or without using the class name. That's all for this video guys. Don't forget to like and share this video, subscribe this channel if you are new, and leave your valuable comments in the comment section below. Thanks for watching. See you in the next